Good afternoon, and welcome to today's webinar of the Green Chemistry and Commerce Council entitled Advancing Green Chemistry, Barriers to Adoption and Ways to Accelerate Green Chemistry Across in Supply Chains. My name is Joel Tickner, and I'm the co-director of the Green Chemistry and Commerce Council. The Green Chemistry and Commerce Council is a business-to-business network of companies across sectors and supply chains formed in 2005 that collaboratively advances green chemistry across sectors and supply chains. Within the work of the Green Chemistry and Commerce Council, we've had numerous discussions over the last 5 years about how to mainstream green chemistry, about how to bring green chemistry to the point that all chemistry is by nature green chemistry. Several years ago, we were in discussions with several individuals across companies and sectors who asked the question of, if green chemistry is such a great idea, why is it not already mainstream? With that question, we started looking at the question of, well, what is holding back green chemistry? What are the barriers to adoption of green chemistry, and how do we accelerate those across supply chains? With that, we commissioned Tess Fennelly of Tess Fennelly and Associates to undertake the research that you will be learning about today. That research has been presented at the Green Chemistry and Commerce Council's annual roundtable in April, and has been presented on numerous meetings to date with different stakeholder groups. But we officially launched the report just about a month ago. So today is the official launch of the report, and Tess Fennelly will be presenting today's webinar with a panel of expert discussants across the supply chain to reflect on the report's findings. Tess Fennelly has over 20 years of consulting experience in specialty chemical and polymer related fields. Tess also has 11 years of industry experience with positions in sales, business and market development, marketing communications, strategic planning, and mergers and acquisition. Her extensive background in traditional sustainable chemistries includes adhesives, coatings, plastics, specialty fibers, and specialty chemicals. She has worked for Segetis, Air Products and Chemicals, American Cyanomin, now Cytec, and Stouffer Chemical Company. Tess has a BS in chemistry from Purdue University and an MBA from Lehigh University. Indeed, Tess is the ideal person to have taken on this research, who understands chemistry, understands chemical industry supply chains, and understands the challenges and the opportunities for green chemistry. So with that, thank you, Tess, for leading today's webinar.
Thank you, Joel. I'll wait here until the, oh, did you want to address this, Cole?
Let me jump back. Due to the number of participants at today's webinar, all lines will be muted. And if you have a question or comment, there'll be time at the end of the presentations to type those in the question and answer box located in the drop-down control panel at the top of the screen. And we'll answer those questions at the end of the presentation. So with that, now I'll pass it to you, Tess.
Okay, get logistics going here. I hope everybody can see the screen. So thank you for having me speak, and it was really an honor to be able to do this work for the GC3, important work that helped us learn a lot, and I hope it will for you today too. And I'm very excited today to have panelists with us to give us some real-life examples of how the deterrents and the accelerators that we're going to talk about have affected the supply chain and different points in the supply chain. So you'll be hearing from them later, but I'd like to introduce them. We have Mark Sugar, who is the Director of Product Advocacy and Policy at Eastman's Global Public Affairs and Policy Organization, where he focuses on product issue management and public policy position development. Mark has been with Eastman for 39 years, where he spent the majority of his career in various health, safety, and environmental assignments. As you know, Eastman is a global specialty chemical company that produces a broad range of advanced materials, additives, and functional products, specialty chemicals and fibers, and they are our chemical, or Mark is our chemical industry representative in the supply chain. In the center of the chain, formulator and brand company, we have Wreath, who is the R&D director at ITW Pro Brands. Illinois Toolworks is a global diversified manufacturer of specialized industrial equipment, consumables, and related service businesses. And Lee leads the innovation efforts for the research team for ITW Pro Brands, which is a formulator, manufacturer, and marketer of products for industrial and institutional hygiene markets. Lee has over a decade of experience in developing new products and leading successful market introductions in chemicals and plastics with companies like ITW, Segetis, and Milliken & Company. And then on the retailer side, we have Alexis Ludwick Vogon, who is the Director of Corporate Responsibility and Sustainability for Best Buy. As you know, is a multinational retailer of technology, entertainment products, and services. And in this role, Alexis oversees the company's environmental strategy and programs, including advancing sustainable products, reducing carbon footprint, and complying environmental laws and regulations. And Alexis has been with Best Buy for 13 years. So we have a really experienced and knowledgeable and an exciting team to talk about this after the initial introduction. So let me get into this. When the GC3 asked us to do this work, really the overriding questions were, why isn't green chemistry in wider use? And what is the means to accelerate availability and adoption? And certainly there have been a number of efforts to accelerate green chemistry use, but the adoption rates remain low. And this is a pictorial to demonstrate the supply chain has so many layers, and if you think about those wheels as turning and there are more participants in those wheels than are depicted, you're going through many, many different companies, many, many different applications, and they can change. So it's been quite slow. So what are some of the things that have contributed to this? Well, certainly a very complex supply chain. This is just one supply chain. I thought it would be a good example. It is a bit older, something that I put together a while ago, but I thought it really demonstrated how complex the supply chain, and also, interestingly, we can think about where our panel participants are positioned. You've got the raw material supplier, polymer modifiers, as Eastman for ITW. With Lee, you've got in a formulated section, maybe not adhesives and coatings per se, but certainly in formulated going into technical textiles, which you'll see over on the right. And then Alexis is representing Best Buy as the retailer. So between them, there are so many other players, so many companies under each and individual applications. So certainly the supply chains are really layered and complex. And it's taken decades for these supply chains to reach their current state. The vantage point is very different at each point in the chain, and you'll be hearing that. Lee is going to see something completely different from Alexis and from Mark, and from all the other points in the chain. Where you're looking, up or downstream, or to your competitors, is going to be quite different. Changes at one point in the supply chain can have a ripple effect, and we'll be talking about that a little bit more. But an important message is that when we're working to get green chemistry through faster, we really want to look beyond the confines of your position and view in the supply chain and think about how it's going to affect the full chain. And certainly before any green chemistry discussions are started, define what you mean by green chemistry. It isn't essential to pick a right definition, but it is essential to be on the same page. So it may not be bio-based, may not be your definition of green chemistry, but you have other parameters, and it's very important to have that. So certainly green chemistry definition and supply chain complexity are just two of the issues. And we identified 9 issues that misalign the supply chain and slow green chemistry adoption. So beyond green definition and supply chain complexity, we'll talk about incumbency. Certainly, competing with an infrastructure of a mature supply chain is a challenge for any new entrant, whether they're green or not. You've got entrenched relationships. You have low costs generated and facilitated by very large-scale production and logistical efficiencies. You have multiple suppliers and sources that are creating competition and lowering shortage risks. It's very much an incumbency is very hard for new entrants at any point. So as an example, the plasticizer industry. It's a global industry with 11 billion pounds. They're supplied globally. And so meeting the global volume needs and the price performance, the knowledge of the industry is really a hurdle for new companies coming in thinking about new plasticizers. Confusion is another issue. Conflicting campaigns, research studies, and various restrictions produce widespread uncertainty about what chemicals are and are not safe. Take BPA. It's not safe, right? Or is it? You've got studies saying that BPA is safe. You have studies saying it's not. You have regulations saying that you can't use it. Those regulations may or may not have been overturned. It varies globally. And which form is BPA safe in? Is it safe in your eyeglasses for polycarbonate lenses? Is it safe in your DVD discs? Is it safe in that can coating for your food? Is it safe in the powder coating that's going onto your chair? Is it safe in the thermal receipt that you're handling when you are getting a receipt from a retailer or a gas machine? So it really, there's a tremendous amount of confusion about what is and isn't safe and when you should make a change or not. Switching risk. There's a real concern that switching to a green chemistry alternative could lead to product failures, market failures, hidden costs, brand tarnishing, and others. So a hidden cost example, a metal cleaning company decided to switch to a greener solvent with a better VOC profile, but their throughput was so significantly slowed because the drying times were so much slower. It was a real hidden cost and bottlenecked their operation. Brand tarnishing, I think we're all aware of what happened with the sun chip bags and PLA. Certainly the sun chip bags were the corn-based polymer, which was compostable and very the right step towards greening, but the noise became such an issue that they had to go back to the drawing board because it did tarnish their brand for a while. Price performance. Certainly a hot button. It's the most cited reason for the slow adoption of green chemistry. You have entrenched chemicals of concern that have set the standard for price performance. And interestingly, too, they're working well and the price is good. So that's an additional hurdle in itself to come in there and say, well, look, we've got something else to take away the product that you actually like. And green chemistry as a performance factor is very tough for customers to quantify, who are particularly customers who are focused on dollar per pound pricing. So we've got forces in the market that are looking to change this. And an example is a retailer said, you know what, we really want a greener solution for our lawn and garden product. And several companies in the supply chain went back and they did some work and took a look at taking the chemicals of concern out, successfully did so, and presented the product, but it was a little more expensive, and the retailer rejected it. We heard these stories quite a bit during our interviewing for this work, and the sustainability teams and the brands and the retailers are working very hard to drive green chemistry and to pull it through and sustainable solutions, but oftentimes procurement is turning down the products. And so there is certainly some conversations and communication that needs to be fostered. We heard that quite a bit. Supply and demand. It's very much a chicken and egg dilemma. You've got new production that's requiring hundreds of millions of dollars and years to establish. And then you need demand to justify that investment. And conversely, you've got customers who are expecting a new technology. Once they've qualified it and they like the technology, they want it to ramp quickly, they want it to perform seamlessly, meet large volume needs, and be available from more than one source. So are you willing to take the risk for a trickle-up effect, build a $600 million plant, and then get sales? That is quite risky. Are you going to spend money as the consumer testing it to get the new technology approved into the product, and then the supply actually doesn't materialize? So some applications also for additives require 5 million pounds for one application. That can really put pressure on a new manufacturing facility. So supply and demand is definitely pressuring the supply chain and misaligning it. And then transparency. Often suppliers need to protect their IP or trade secrets of a new technology to shield investments and poaching by competitors. And yet suppliers need disclosure to mitigate the risk to handle and sell products with unknown ingredients that could be chemicals of concern. A lot of transparency today is occurring by force. You have organizations like CDHC and Healthy Hospitals. You have Safer Choice program, retailer chemical policies, and the transparency and conformance certifications can be costly and time-consuming for suppliers, but it is occurring. But currently, it's slowing the process as everybody's trying to get their foothold on what can and can't be done and what should and shouldn't be done to have a viable business. And then new technology access and placement. Finding and vetting green chemistry materials still remains a weak link. You have material suppliers who come up with a new material struggling to identify who's willing to be the early adopter and which segment should I go to. And then you've got customers who are struggling on where to look for new solutions beyond the traditional supply chain. An example is with supply chain complexity is mining companies, a recent example actually, who are looking for some better solvent technology. And they're relying on their equipment suppliers, who rely on their jobbers, who rely on their formulators, specialty formulators, for the solution. But the formulators are really getting a diluted message, if a message at all. And then the solvent suppliers may or may not have access to those specialty formulators. So getting a great new technology into the hands of those who would really value it is often a hurdle. So currently the misalignment issues are far outweighing the main drivers. And the main drivers are government regulations and consumer awareness. And with government regulations, certainly they have forced the elimination or reduction of some chemicals of concern, and it is a driver. An example was the Center for International Environmental Law found that there was a spike in patented non-phthalate inventions that correlated with European REACH regulations. So it is happening, and it's been documented. And consumer awareness certainly has forced change as well. It was consumers who demanded BPA elimination in baby bottles. And so those drivers are certainly playing a part. But one of the reasons that we found it's really slowed is that traditional thinking is driving behavior and decision making. And this is an example of a strategic tool. It's Michael Porter's 5 Forces model that many companies use. And it's to really position yourself within the industry and understand what is the threat of new entrants and how can we protect ourselves against those? And what's the threat of the product substitutes and how can we protect ourselves against those? And how can we protect ourselves against buyers who are too powerful or suppliers who are too powerful? It's very much a defensive and competitive positioning. But models can be adapted for beneficial change. And we've identified 4 green chemistry accelerators, and they can be applied in more of a cooperative effort based on these 5 forces principles. So embracing new entrants and new supply, bringing them into the fold, maybe combining them with your business, providing more of an access and placement of technology for the supply chain, leveraging the power of buyers and the power of suppliers by virtue of collaboration, compromise, technology forcing, and enhanced education. So certainly collaboration is a really powerful accelerator. And it provides a way to close the gap between what players in the supply chain say they want and what others in the supply chain can deliver. So certainly strategic alliances, setting expectations, overcoming hurdles early on with collaboration, and having joint solutions. Some examples are crowdsourcing. A recent one is that there's a thermal paper supplier and a chemical company and a retailer who plan to share their successes in finding an alternative to some of the phenolics with the industries once it's far enough along. ZDHC. So collaborative efforts are definitely helping the industry move forward faster. Compromise. Accepting the notion of continuous improvement. Taking a starting point, but don't look for the final perfect goal, the ultimate goal, but take it as a step in the right direction. And a classic example is the Model T Ford. You could have it in any color as long as it was black. And we certainly know that there's a lot more variety today. Another one is recently a company wanted a bio-based product that was a non-food source. And the company said, you know, we have a plan to get there, but we're not there today. And so the first generation of the product is going to be based on a food source, but here's how we're going to get there. And that's a step change. And compromise can help the parties in communication to get there faster. Technology forcing. A little controversial sometimes because people say, well, maybe that's not a collaborative effort. But in fact, it is if you realize that that is the way the industry is going. It's that decision maker with buyer powers can force change. So jump on the bandwagon, look at the de facto regulation, and supply them. A really good example, I think, is Tarkett, who is a global flooring manufacturer of vinyl flooring. And recently they said, we're not going to put phthalates in our vinyl flooring anymore. And they buy millions and millions of pounds. So the companies supplying them are needing to provide them with alternatives. They picked alternatives, and there may be future alternatives. And it's not just one. It's actually a formulated bundle. But it is an alternative to the technology, and they're leading the industry. The other flooring manufacturers are sitting up and saying, you know what? Well, if they can do that, maybe we should do that too, and the alternatives are out there. And then enhanced education. You've got better educated consumers who are accelerating a demand for green chemistry. certainly consumers are more aware of cleaning ingredients, for example, and what's in them, and demanding certain ingredients or certain products that don't have them. A recent example was consumers have been upset about GMO additives in their food, and Chipotle made an announcement to take those out. Consumers can accelerate the demand and make a change. And there's been a lot of talk and work in getting the workforce trained initially in green chemistry to accelerate adoption. If you're starting with a green chemistry design, that certainly is the fastest way to accelerate adoption. So these 4 accelerators should really be part of the toolbox to drive change and get green chemistry through faster, and it can tip the balance in favor of change. So I'd like to open this up now to the panelists to give us some feedback on the deterrence and the accelerators. And we're going to open this up to Mark, Lee, and Alexis. They're going to talk about deterrence first. We'll go in chemical supplier, formulator, brand owner, retailer order, just to keep some consistency going. So the first question is really, from your perspective, and on the inhibitors in the supply chain position, can you give us some examples of inhibitors that have really affected your supply chain? Mark?
Okay. Yeah, this is Mark Scherger. Hey, I'd like to talk a little bit about switching risks to start with. And for context, we are far up in the value chain. We're not quite at the extraction phase, but we're at the next step down. And so we make materials that go into materials that end up on the consumer tables or in their houses. And you know, what I can do is tell you that we actually have several products that we consider green that haven't been getting a great play in the marketplace. But when you consider the complexity and you consider all the issues, really that's not too surprising. And we're really trying to work through those. From our perspective, it takes anywhere from 3 to 10 years to put a new molecule on the market. And so, you know, that's really a significant investment in time and money. And even though we use a rigorous stage gate process to traverse this time frame, it does take a lot of time. This can be broken down into different areas like research and development, and there's associated costs. There's requalification costs. We can't throw something out to a customer without having them make sure that it meets their needs. There's contractual agreements, and sometimes those need to be worked out. There's possible capital costs associated with transportation, storage, and even manufacturing equipment. And one of the things we found in actually, and we've seen in the marketplace, is will the greener product really be compatible with existing waste and recycling streams? For instance, we're aware of some new products, plastic products, that have caused some issues with existing recycling streams. And that really doesn't make the recyclers happy. So that's really kind of an extension of the value chain beyond the consumers. That gets into more or less the circular economy issue. And so you really have to understand where the waste is going and how that's going to be handled. Of course, there's safety testing and risk evaluations that need to be conducted, and possible registrations. And these include government registrations for food, drug, device, cosmetic ingredients, and especially ag products. A lot of regulatory drivers out there right now, and those are a barrier to change. Once you go through a registration, you don't want to have to go through another one. And then finally, on switching risks, marketplace acceptance. You know, is it better, or is it as good or even better than what's on the marketplace right now? And is it value added? If it's not value added and it may not work as well, chances are it's not going to get accepted. And then finally, I'd like to mention that are there other trade-offs? For instance, you may have a product that has a well-defined toxicity and risk profile, and when you move to a new product, you may not have that data. And so as you start developing that data as the product is on the market, you may find out that you have some regrettable substitutions, and those really are not good. So that really kind of deals with some switching risks. And I guess the other one that I'd like to mention is just defining green chemistry. And I guess to paraphrase a cartoon character, it's not easy being green, but it's no easier knowing if you're green or not. Greenness is not easy to define, and it's really very complicated. It's almost personal, and so there is no consistent definition. Some consider just hazardous or health hazards to be green, and these are carcinogens, mutagens, reproductive toxins, persistent bioaccumulative toxic, ecotoxic materials, endocrine disruptors, sensitizers, and the like. Some also consider exposure components, so you have more of a risk approach to understanding is something green or not. You can layer on top of that a lot of life cycle assessment parameters. What about the impact on energy? What about waste? What about water? Loss of habitat? And is it greener if it doesn't work? And then also, what about individual perspective? And this is something that some people are willing to accept more perceived risk than others. And so there's some personal issues out there. And I think all this leads to confusion in the value chain. I've been personally involved in this conversation for over a decade, and it's not getting any easier. And I think some social media is making it even more complicated, and that's something that we really need to consider. And that really gets into the education component that Tess mentioned. And one thing that I would like to point out is green chemistry really is a value chain issue. It's not really only up to the chemical companies to say, hey, I've got a greener product, use it. The brand owners, the retailers, the consumers, we're all in this together, so we need to figure out how to do that. And I think lastly, I think the chemical industry is uniquely positioned to provide technical information on our products and provide information and answers to our customers and to our customers' customers. And that is one way that I think that we can help solve this. So I'll turn it back over to you.
Lee?
So this is Lee Wreath. As a formulator and manufacturer of blended chemical products, I have a little bit different perspective. We are also a brand owner, and so our primary function in developing new products in the chemical space is to develop something that our end user finds value in. In the end, that's what it's about. And we serve the industrial channel, so we are focused on the factory worker that has to clean off a part, or a guy that's distributing cable boxes and needs to clean his hands between installations. Like the consumer channel, there is a small portion of our end user market that values the green story, the environmental conservation aspect of our product, but that is a small minority of our market, similar to the consumer market. And so really what they're after is, I need something, I have a job to do, and I need a tool that helps me do it more efficiently, more safely, and with less cost and use. And oh, by the way, I need to comply with all the various regulations out there. And so as we look at ways that we can incorporate green chemistry into our products, that is of our foremost concern. And so price performance, as Tess noted out, was probably the most common inhibitor. Certainly in our place in the value chain, that is the case, that price performance is a big issue. We can sell on lower cost and use, not just lower cost. It's a little tougher, but it can work. But what we can't do is sacrifice on performance of our products. And so it needs to be either more, if we come out with a new product, it needs to be either more efficient, more safe, or lower cost in use. And you can't sacrifice any of those things to get people to switch. And so that's always been the challenge with new chemistries is that balance. I will say that after about 10 years of this really being in the growth mode, that we are starting to see more and more cases of green chemistry solutions that do offer an advantage from a cost and use perspective. I think that was not true as much true 5, 10 years ago, but we are starting to see more of that. So that's probably our biggest challenge, is that in the end, our customers are not willing to pay more for a better environmental story. We need to save them money in what they're doing. The other issue that I think comes up quite a bit is, I'll use a more general term of regulatory burden, and I think transparency, Tess alluded to, is certainly a part of that. And you know, the regulatory efforts to green up products and so forth have been effective in some ways, but in some ways actually are working at cross purposes. And to give you an example, you know, Tess touched on one of them. With the more attention to environmental and safety concerns, the labeling programs have become much more and more prevalent. And of course, that drives a real risk to folks like me who are trying to develop differentiated products that I can protect through either patents or by trade secret. And if our trade secrets become disclosed, there's suddenly a great loss in value in what we spent a lot of time and money developing. At the same time, beyond just the transparency concern, there are certainly regulations that we have to comply to, and in some respects we view that as an opportunity. If I have to eliminate certain chemicals of concern and I can do it better than my competition, that's an opportunity. But at the same time, accompanying that are a lot of burdens around communications, around changing regulatory landscape. Just giving you an example, in the first half of 2015, in addition to reformulating to meet new regulations, which I fully expect, we had to complete our OSHA's new HAZCOM standard for GHS, Global Harmonized System. It was a 2-year effort in which we had to change every single label and every single SDS for all our products. You can imagine the dozen of people that it took, a significant amount of their time over 2 years to do that. At the same time, California required us to report every formulation that we have that has a chemical composition that could contribute to VOCs in the consumer product regulations. This is all happening at the same time. And so you can imagine the crowding out of innovation activities that we have by trying to comply with those regulations. At the same time as that's happening, CARB is threatening, or at least talking about, eliminating the VOC, low vapor pressure exemption, which formulators like myself have spent the last decade trying to comply with their consumer product regulations by using these VOC LVPs. So that shifting landscape, it creates a great deal of complexity for us as we try to formulate and develop new products. So there's a couple examples for you. Hopefully that gives you some insight into some of our challenges, and I pass it on to Alexis.
Hi, this is Alexis Ludwick Vogon from Best Buy. Thanks for having me here. It's a pleasure. So I work for Best Buy. We're a leading provider of technology products, services, and solutions, as I hope many of you know. We do operate in Canada, the US, and Mexico. We have over 125,000 employees and more than 1,600 stores. And as I think many of you know, we sell many brands, and we also have our own private label brand. So I'm going to talk a little bit today about some work that we've done on our own private label brands, but then how we're also pushed to look at the brands that we sell in our overall store. So Best Buy's mission is to ignite human potential through technology. It's a pretty lofty mission, and clearly it relates to green chemistry, because of course we want all the products that we sell, manufacture, sell, and use, that they are safe for consumers and don't have any adverse impacts. So what I wanted to talk today with this group on was actually confusion, which I think having the retailer show up in a chemistry webinar, I think confusion is probably the most appropriate place for us to be. And I wanted to talk specifically about flame retardants. We've had a little history with flame retardants where we started hearing a while back from a number of stakeholders about the sustainability of certain flame retardants. And flame retardants have long been regulated. So I think that we've gotten pretty good at product level or chemical compliance. There's, state, national, international regulations on certain flame retardants through RoHS, REACH, a couple U.S. states. But then on the other hand, flame retardants in electronics are also required because flame retardants have a power source and there is a potential for catching fire. So we're in this conundrum in a way where we have to have them, but we're getting pressure from stakeholders that some are good, some are bad, some are regulated, some are not. And where it gets confusing is when the science is not exactly clear. So we're getting pressure from stakeholders. It's not regulated. It's this gray zone where the science is just not unanimous, and that leads the retailer to wade through the science. Talk about confusion. So there are not a lot of chemistry professionals that are working at retailers. So this is something that has been daunting, and we definitely need to leverage good partners throughout the analysis. And when we kind of make these decisions, there's a lot of risk for us, and Tess and the others have really talked about many. We really risk having an unfortunate substitution or switching risk, as Tess talked about. Or we try to switch to something, a different either chemical or solution, and we realize that we can't scale to the volume that we need, or the price, as we've talked about, or performance is different. And then when a large retailer makes a decision on certain chemicals, we're really having the retailer as a regulator, and I'm not sure that that's where the retailer should play, or if retailers in general are comfortable doing that. But clearly, we always want to do, as I know everybody does, what's right for the consumer. And if we move late on something, we risk damage to our brand as well. So we don't want to be seen as not paying attention. But when it's not clear, it's hard for us to make that decision. Additional confusion is also caused by kind of the complexity of the supply chains. So actually getting accurate information on something that we haven't historically tracked and has gone through multiple companies and manufacturing sites and factories to get to the final destination. It just can be difficult to trace through the supply chain. So interestingly, the solution that we are piloting right now around flame retardants is we actually changed the design to our television. So for our Insignia TVs, we have a number of SKUs where we've moved the power source from inside the back casing to outside the back casing, and this greatly reduces the number of flame retardants that are required to ensure fire safety. So this is just a pilot. We don't know if we can actually continue with this through the complexities of the supply chain, but it's a way where a retailer has, we've tried to change the design to meet the stakeholder needs universally. And I know Tess brought this up in her research, but BPA, that is something that retailers have been working on for a long time, and I could have used that as an example, thought about it, but figured I'd go with something new and fresh. But certainly BPA and receipt paper is something, and in products is something that I think kind of goes through almost every single one of the barriers that Tess talked through. And with that, I'll hand it back to Tess.
Oh, that's great. Really interesting insight from different parts in the chain. Thank you. So those are the deterrents and the things that have stumbled, although a couple of solutions were presented. A really interesting one, Alexis, on the power source design change, for example. But I'd like to ask you about and have a discussion about the accelerators for change and the development of collaborative, cooperative models. Do you see any examples occurring at your companies and in the industry, and are there some other factors that we need to consider? And so, Mark, can we start with you?
Sure. Yeah, I think that there are. I think that one of the things that we are doing is we're talking to more than just our chemical industry peers. We're really trying to get a better understanding of what are the needs of the marketplace, not only our customers, but our customers' customers. Here several years ago, we've actually started conversations with different retailers, and I think it was eye-opening to us to see what they were asking for, and they're very good at what they do, and we're very good at what we do, but we do different things. And I think initially what we needed to do was sit down and make sure that we were speaking the same language. We need to build credibility and build trust. And I think that is a way that we can actually move towards solutions that ultimately the consumers want.
Lee?
Yeah, so I think the one that really struck a chord with me that I've seen really reap benefits is the collaboration accelerator. You know, traditionally, and certainly prior to coming to ITW, I was more on the raw material side. When we invented a new chemistry, we would try to protect all the IP, so no one could ever carve out little niches and protect their own little areas as far as downstream is concerned. I think raw material suppliers are seeing that the benefit of allowing their customers to, they'll cover the broad things, but collaborate with their downstream customers like formulators like myself, and allow them to carve out areas of IP. Because again, we have limited resources. We have to focus on those areas where we can differentiate ourselves from our competitors, and if we can do that through a formulation that uses new chemistry, and the chemistry provider allows us to protect, within the narrow areas that we specialize in, to carve out some IP, that really gives us some more incentive to work in that area. And so, because we recognize then if that's available, not only is it available to us, it's available to our competitors, and so that really gives us incentives to move fast and to focus on these areas, versus if it's something we don't feel we can protect, then all of a sudden our incentive to work on it goes down. So I think that's a big area where I'm seeing companies more willing to do that, and I think that's a huge benefit to getting things into the marketplace.
Great. Alexis?
Thanks. I think that one of the accelerators for us has definitely been the collaboration as well. So certainly, since I talked about confusion, one of the collaborations that really helps us tremendously is when we can go to a well-respected, usually NGO or academic organization or kind of an external group that can really help us wade through some of the science and can help us make a kind of cross-industry collaboration decisions around things. And clearly, I'm going to state in a self-serving way, but the GC3 has been a great place for me to go to meet with other retailers as well, believe it or not, where they are also looking at chemicals and kind of talk through in a non-competitive or pre-competitive way different approaches and what has worked and hasn't worked, and then also some of the work that we've done around working with chemical companies. It's just in my day-to-day, we don't meet that far into the supply chain, and so it's really refreshing to kind of hear their perspective and what makes it more difficult or difficult for them. So those collaborations really are critical, I think, for kind of making movement forward.
Oh, that's great. Some really good insights. Thank you, all of you. There is one last piece as we start to think about some of the next steps. There certainly are quite a few strategic initiatives or process plans that could be developed and utilized for next steps, which would take some work putting together, but there's also some things that companies can start to do today and start to think about today as they enter into these discussions and start to apply accelerators. And it really is going to involve a broad range of supply chain stakeholders early and allow open discussions and sustaining collaboration to be the first and potentially the most important step in getting green chemistry through. So just as a rough example here, let me pull this up. And I'll try and, I don't know how that, whoops, I hope you can see this. It's just a rough checklist, and it's really to provide a framework to help identify early on maybe some of the sticking points, maybe some of the challenges, or maybe a need for common language, and maybe some ways that there might be compromises for future cooperative efforts. So when companies are getting together, whoever the supplier and the customer is, and there could certainly be more parties in this, review the definitions. Review and discuss the definitions of green chemistry so that you're starting off on the same page. And then why are we even having this conversation, and what is our high-level vision for this? And then a really important piece is to map out the supply chain. What do we each know about the supply chain? We'll be using this a little bit later for thinking about the impacts. And then, let me get to this here. This is a Word document, so I apologize. Define and review what some of the needs and the concerns are. So, for example, each should think about what EHS needs do we need, environmental health and safety. What are some of the toxicity results that we need? What kind of VOC requirements, sensitivity, renewability, biodegradability, what % bio content do we need or not need? What are some of the EHS needs? And then what is absolutely required for adoption, and what might we be able to compromise or have trade-offs as we start to bring this through. Then also think about what are the specific technical product requirements, and Lee talked about some of this. There are some areas where you just can't modify, and it's absolutely required for adoption, but maybe there's some places for trade-offs. What kind of impact resistant, odor, electrical properties, biodegradability is above, but whatever the technical properties are, and then certainly listing business needs and requirements, talking about price performance, how are those going to be measured, savings, trade-offs, et cetera, supply and demand, what kind of timing, need for a second source, global. We really haven't talked a lot about global supply, but that adds such greater complexity to the supply chain and registrations. Switching risks. Change in the infrastructure, change in the supply chain. How are we going to help, and what's required, and where might we be able to relax our standards? And then the strategic needs, transparencies, global supply, registrations, and others. And then let's take a look at that supply chain that we mapped out together and anticipate what the impact and the needs of the supply chain are. So how is our project going to affect the supply chain? What do we need to do? How can we communicate, educate, and speed the adoption? So what kind of impact is it going to have? Is it going to have a change in the flow and structure? Do we need to have some communication? Is there a certain type of blocking or resistance that we're going to have to anticipate? What new infrastructure costs may be happening? For example, maybe it's not ours, the customer and the supplier. Maybe it's someone else in the chain who's going to have to change their equipment that they have in place. Well, if we want this truly to happen faster, how are we going to have it happen? Competitive response. Is this really going to change the supply chain for somebody in the chain, and then their competitors are going to come in and impact it? What kind of costs, registration, certifications? Some of you talked about that as well, and others. And then certainly, can we engage others in the supply chain to accelerate the effort? Who is that? What kind of parameters and requirements? How could it be formal consortia or other? And what kind of issues and concerns? And then certainly, maybe there's some supports and needs that could be done to scale the technology that we can have a joint effort on. Investors, tax credits, existing assets that are in place that might be able to be utilized, others. And then review the decision guidelines. I mean, certainly in partnerships, there's some very intricate stage gate and go, no go and partnership decision networks, but let's review those and make sure that we're on talking the same language, and then troubleshoot it. Keep the communication lines open. This isn't a one-time document. It's kind of a living thing. Review those obstacles and then work to resolve collaboratively. So this is really something that this is kind of maybe a back-of-the-pocket checklist that companies can look at to make sure that those conversations are starting and being had. And by having those open discussions and utilizing a checklist like this, or one that you put together, it can provide a way to close some of the gap between what each member in the supply chain says they want and the lack of understanding of how each position in the supply chain might be impacted. And so the complexity of the supply chain can be addressed. And the green chemistry definitions, the price-performance trade-offs can be reviewed with appropriate competitive and antitrust guidelines, obviously. Transparency will be addressed. Expectations of supply and demand can be shared. You can pave a path for new technology access and placement, and then have a certain amount of risk sharing to agree upon. And this can generate really good conversations to direct thinking, get issues on the table before they become a problem, ultimately greasing the slide to accelerate the adoption of green chemistry. So thank you so much for your time. I hope this has got you thinking and that we're going to help to accelerate green chemistry.
Great. Thank you so much, Tess and Mark and Lee and Alexis, for excellent presentations and also your commentaries on the challenges and the accelerators. What I want to do now is remind you that there is the question and answer box on the right side of your screen, not on the top down, but on the right side. You can write in your questions. And we'll now engage the panelists. Let me ask a starting question. What is the role of government, particularly state and local governments, in moving the scale of adoption of green chemistry? We heard about that regulation plays an important role in consumer demand, but where does government also come in? What kinds of supports or drivers can government provide to help move this along? And it could be anyone. I mean, we could start with you, Tess, and then go along the chain there.
Well, I think that the government regulations can certainly open up the discussions and some of the issues that are affecting industry more broadly. And the role that government can do is to really bring that conversation together of the full supply chain, and that's happened in a couple of instances for certain chemicals of concern where there have been alternative assessment panels, some of which have led to decisions or not for change. Also to bring an understanding to address what some of the hurdles are and create legislation that isn't too restrictive and will block out, potentially stifle innovation of newer and smaller entrants, for example, in favor of large companies. So really evening the playing field, so to speak.
This is Mark, and I think 2 points. One is I think the government is actually behind the general public sector, or excuse me, the private sector here with driving green chemistry. I think the marketplace is a bigger factor at this point in time. But I see where the government is leading is in some of their procurement programs, where they're actually specifying that they for their own use would prefer greener products. And I think this is something that we're looking at, and I know others are too.
Yeah, this is Lee. I was going to make the same comment. I think the government, in addition to being a large body that passes laws, it's also a big customer, and I think some of their incentive programs, USDA has one, and certainly the DFE program are good incentives that people can take advantage of the fact that there's a heck of a lot of business to be had with the government that very similarly to what big retailers do.
This is Alexis. I think that the government is, in some ways, regulation can just provide pure clarity, which then just goes straight to action, which I think at times can be very useful to have that clarity. It can be difficult, though, if it is regulated by, let's say, a small state or maybe a large state, and so you get a very small kind of part of the global supply chain that is regulating something, and then it drives kind of the international supply chain. And I do think that they've got the incentive programs, so Safer Choices now is very helpful, because it again, in an incentivizing manner rather than a regulatory manner, it helps provide some clarity.
I just have one last thing. This is Tess. Two pieces. One is the fragmentation of regional regulation has been a burden to a number of companies who are having to make sure that they stay on top of what the regulations are by city, region, state, country, etc. And so I know we don't want to go to one conformity, but recognizing that that's an issue. And then also the incentive programs like BioPreferred, for example, the USDA program, started out as a U.S. government buying program, but actually people are using that as a model for wanting a product that's BioPreferred, whether it's for their purchasing needs or not. So that's translated to be a positive.
Great, thanks, Tess. I think this is a question directed at Lee, the issue of transparency and protection of intellectual property. How have some of the European regulations like ROS and REACH, or even some of the state policies, affected this or impacted risks in protecting IP? Is there a greater willingness towards transparency, given that there's more requirements to actually be transparent?
Well, I mean, I just think that in general, it's viewed as a risk that the more that we have to disclose, there's a greater risk that our ability to be differentiated evaporates. So I think it's just by definition they're somewhat at odds with each other. It does maybe perhaps drive some more patent work versus trade secrets. Force us to adjust how we protect things. But I do view it as a somewhat at cross purposes with each other. If green chemistry is a driver of bringing new products to the marketplace, if I can't protect the adoption of those new chemistries, then my incentive is less. I think that's just the risk of some of those transparency issues.
Great. And let me ask you a follow-on question on the challenge you brought up about price and performance. What kinds of support would a company at your part of the supply chain need to help you overcome that barrier of price performance to move green chemistry alternatives into the marketplace?
Well, I think the main thing is, and I don't know if it was Tess or someone touched on this, is a vision. In other words, through collaboration, you can start to maybe you suffer some margin loss or something for a year because you see the vision of where it could be, and so there's collaboration there to work together. And again, there's trade-offs there. If you buy at this higher price for a couple of years, you have the ability to get some IP or whatever by collaborating with both, particularly for us upstream, but also perhaps downstream. Those collaborations allow you to make those trade-offs that benefits both of you. And I think just the more willingness for people to collaborate and make those trade-offs, I think, has helped us at least certainly adopt some of the green chemistry products out there.
Great. And I'm going to ask a question to Mark, but before I do that, two quick things. One, first, the slides for Tess's presentation will be available on the GC3 website. There were no slides for the other presentations. Second, I would ask those on the call if you have particular examples or input or ideas into next steps to take some of this, the lessons learned from this report. Please do put those in the question and answer box, and we'll take those in as input into the GC3 direction moving forward. With that, Mark, you raised a key challenge for a company at the chemical industry level of the supply chain is the costs and the time to market, right? All of the efforts in R&D and requalification and contract and contractual agreements, capital costs. So what helps you overcome those challenges to move a green chemistry option forward, particularly given incumbents that might be in the market that might be your own incumbents, or they might be incumbents from another company?
You know, well, I don't think you'll ever have certainty that a product that you're in the process of developing will be a home run type product. But if you can help understand, or if we could better understand what the needs are, what the drivers are down the value chain, it'll give us more certainty as to, do we put the resources into developing those products? So, and I think that is, again, getting back to collaboration and communication, understanding. And it doesn't necessarily be just our direct customer. It has to really be kind of the overall value chain. How that takes place, I don't know. And one of the things that was briefly mentioned, but I'll mention it again, you can butt up against some issues with antitrust if you don't watch it. And so there has to be some care in how you communicate within the value chain so you avoid antitrust issues. But I think that we can figure this out as time goes on. And I think better understanding of both ends and the middle is one way of moving forward.
Great, thank you. Alexis, retailers are not necessarily, and most are not, experts in chemistry and don't necessarily have the technical capacity to understand the challenge, or what may or may not be safe or dangerous, as well as what the potential alternatives would be. Given your example with the televisions, what would be the most effective way for a retailer like Best Buy to reach out through their supply chain and start having discussions about where there are options for green chemistry solutions?
I think, thanks for the question, and I think that absolutely correct. We don't have that expertise on staff in general, and we do rely tremendously upon other experts outside of the organization. And we have started having those individual conversations with our Tier 1 suppliers and have started asking additional questions that then have to kind of work their way up through the supply chain. So it starts with that conversation with Tier 1 suppliers. And a lot of times it is not the person who's done the studying on the chemicals that might be having that conversation. It actually might be the merchant. And so you're even then another step removed. So it can be difficult at times. There are many other retailers that have gone to software to try to collect information on a more regular basis. And I think that's proven to be very effective.
Great. Lastly, how does, I mean, and it depends on where you are in the supply chain, how do we know, what kinds of tools are you using to know whether these are greener options, and how do we move those? And in cases, are there alternatives for each individual chemical that you're looking at? And when there aren't, how do you sort of push the supply chain in that direction? It's a big question, and it's sort of a combination of multiple questions we got from participants on the call. I don't know whether you want to start with that one, Tess, and then we can move down.
I'm actually going to give it to the people in the supply chain because I think they're facing it every day.
I think when you start talking about tools, I think one of the critical factors is knowing what the tool is designed for, and equally important, knowing what it's not designed for. So if you're talking about a tool that says defines green chemistry, and you're talking only about a hazard-based tool, you need to be aware that there may be some issues that that tool doesn't cover. And if, say, water or waste or energy is important to you, you're going to miss it. So you really need to get behind just the generality of the tool and understand what the tool is intended to do.
Yeah, I think in our case, this is Lee, green to us is largely about safety. And so we take, very carefully review all the different hazards and the accompanying risks with our usage. But so for us, it's a little more cut and dried because with our user base, it really is, we're talking about skin irritation, skin sensitization, eye irritation. Obviously, toxicity is a big deal, of course, too. So for us, it's a little more cut and dried that green to us is safer, and the environmental benefits more around where it goes afterwards versus where it comes from. We're a little less concerned about where it's coming from than we are about where it's going afterwards.
Great. So let me ask a final. Go ahead, Alexis, please.
Oh, okay. I'll just say that to the one part of the question was sometimes there aren't good answers. What Mark and Lee talked about is there's so many different criteria to look at the chemical, and sometimes you're looking at one and it's a hot, it's kind of majorly red in one category, and then you look at the viable substitute and you see, okay, so it's better in that one area, but it's actually high in this other area. So you really sometimes there isn't a solution on the market that is the perfect solution and performs and is price competitive. So there are those scenarios, absolutely.
Great. Let me ask a final question, and we'll wrap up with this. We certainly heard throughout the conversation that dialogue and collaboration is a key along the value chain is key to accelerating the adoption of green chemistry. The GC3 sees mainstreaming green chemistry as one of its coming goals over the next several years. What are some ways in which the GC3 can take the lessons learned and recommendations from this report and move it forward? And certainly the report has many recommendations, so I won't go to you, Tess, but I'll go to our supply chain discussions for that answer. Do you want to start, Mark?
Yeah, I would. One thing that I would recommend is that there's in addition to GC3, there's a lot of efforts going on, and I think just trying to understand what some of these other efforts towards green chemistry are, and make sure that there's discussion so it can all be pulling in a similar way. I can't say the same way because there are different sectors involved and there's different needs. But one thing we don't want to do is we don't want to further fragmentize this whole effort. And I think that will just cause more confusion and it's more waste, and it doesn't benefit anyone.
Great. Lee?
Well, I think just in general, the platform that GC3 has just is really allows you, or allows them, or however you want to say it, to reach people that from across the different parts of the supply chain. So I think the main thing is to leverage that multi-touching point that you have and get it out there so that people can chew on this, and like this webinar, continue to do things like this is, I think, the best thing.
Great. Alexis?
Yeah, I love the research that Tess Fennelly did and outlining the barriers and accelerators, and I think GC3 could continue to stay focused on those barriers and accelerators, and perhaps create work groups around ones that they think that they can make traction on. So addressing certain barriers, addressing certain accelerators, and gathering those, really being that point to gather the cross-functional stakeholders that need to be involved and can help drive through those barriers and accelerators.
Great. And let me just give you the last word, Tess, before we wrap up.
Well, you know, I actually would like to just address that the GC3 is such a unique, and you've heard me say this, Joel, an organization because you bring people from the full supply chain in the discussion. And the meetings are great. I think they could even be expanded to share, be more of kind of a way to have a common language in messaging. So maybe even having some poster sessions where the new green chemistry offerings are described, because there's not enough time to go through everything. The brand owners could talk about new advances and adoption of green chemistry. The retailers could talk about advances in progress and what's happening, maybe some other tools that are out there, really posting needs from retailers, brand owners, whatever the idea is, but having kind of an information sharing session for some of the downtime. There isn't a lot, but in addition to the conversations and what's happening. So I think GC3 is a great forum.
Great. Thank you so much, Tess. And I'd like to thank Tess, Mark, Lee, and Alexis for the great contributions to today's webinar. As I said, the webinar those slides will be on the GC3 website, and it has been recorded. Upcoming events, the GC3 is co-sponsoring with the German Environmental Protection Agency a conference in Berlin on September 24th and 25th on sustainable chemistry. Tess will be presenting at that on the results of her research along with TrueCost, which did a report for the GC3 as well on the business and economic case for green chemistry. And just to mark your calendars, that the 11th annual GC3 Innovators Roundtable, sponsored by 7th Generation, will be hosted in Burlington, Vermont from May 24th to 26th, 2016. Again, thank you everyone for your presentations and for joining us today on today's webinar. Thanks so much.
Thank you.